After the successful Apollo 11 mission, where the United States achieved the historic feat of landing a man on the moon, NASA scientists found themselves with a myriad of studies and experiments to conduct on the lunar surface. Subsequent missions saw astronauts engaging in activities such as playing golf or operating rovers on the moon's surface. However, the crews of Apollo 14, 16, and 17 were equipped with a unique device designed for specific tests. This extraordinary tool was part of the Apollo Lunar Surface Experiments package, a collection of scientific instruments intended for use by astronaut crews. Among these instruments was a space mortar, designed to detonate grenades on the lunar surface. The primary goal of this active seismic experiment was to utilize explosives to investigate the subsurface structure of the moon. However, the process faced challenges due to the still unknown lunar phenomena, prompting creativity among astronauts and engineers back on Earth. Upon the historic landing, often expressed as the Eagle has landed by NASA, the main objective of Apollo 11 was to fulfill the national plan outlined by President John F. Kennedy on May 25, 1961. This plan aimed to land a man on the moon and safely return him to Earth. Secondary objectives included scientific exploration, deployment of various instruments, and gathering lunar surface samples for return to Earth. The crew of Apollo 11, consisting of Commander Neil Armstrong, Command Module Pilot Michael Collins, and Lunar Module Pilot Edwin Buzz Aldrin, became iconic figures watched by over 650 million people. The missions involved deploying scientific equipment, capturing extensive photographs of lunar terrain, and conducting experiments that contributed significantly to scientific understanding. The music of this historic era resonates with the events, signifying the triumphant landing and the subsequent exploration endeavors on the lunar surface. When Neil Armstrong first stepped onto the moon, uttering the famous words, "That's one small step for a man, one giant leap for mankind," President Kennedy, who initiated the moon landing vision, did not live to witness this historic achievement. Hours after the Apollo 11 mission successfully landed on the moon, a stranger left flowers and a note on Kennedy's grave, stating, "Mr. President, the Eagle has landed." Subsequent missions, following the precedent set by Apollo 11, involved astronauts engaging in a variety of experiments to gather ample data for further research. Activities included collecting soil and rock samples, measuring seismic data, and studying the lunar surface. The astronauts also conducted experiments such as Galileo's hammer and feather demonstration. Beyond their geological objectives, these space explorers drove lunar rovers, planted flags, played golf, and even detonated live grenades using specially designed space mortars, all in the pursuit of scientific knowledge. NASA engineers crafted a unique mortar equipped with explosives for use on the moon during the Apollo 11 mission. Contrary to expectations, this mortar served a strictly scientific purpose. Armstrong and Aldrin deployed the seismic experiment package, laying the foundation for subsequent active seismic experiments in future Apollo missions. Despite speculation suggesting military testing, NASA maintains that the active seismic experiment ACE package was designed to generate and monitor seismic waves for studying the lunar near surface. Various seismic energy sources were employed, including an astronaut-activated thumper device, a motor package housing rocket launch grenades, and the impulse generated by the lunar module's ascent. In essence, the active seismic experiment aimed to gather data essential for understanding the physical properties of the lunar surface and subsurface materials, as well as determining the structure of the upper kilometer of the lunar crust. Unlike the Earth, which is predominantly seismically active, the moon remains seismically quiet, posing challenges in collecting data about its internal structure. Scientists primarily rely on seismic waves to comprehend the layers of the Earth, including the interactions of the crust, mantle, and core as these waves traverse the planet. This process, known as seismic tomography, involves measuring changes in the expected arrival time of waves, and it can be achieved through passive seismic methods, utilizing seismometers recording distant earthquake waves, or through active seismic procedures. On the moon, where the environment is largely silent, seismometers placed on the lunar surface struggled to detect significant activity. As a result, NASA opted for a more impactful approach, resorting to the detonation of controlled explosives to initiate seismic waves and gather essential data. The findings from the Apollo missions contribute valuable insights into lunar geophysics and continue to shape our understanding of the moon's internal composition. The seismometers positioned on the lunar surface failed to identify any significant moonquakes, unlike Earth, which experiences multiple magnitude 5 earthquakes weekly. NASA detected only 3 lunar quakes in over 5 years. Despite this, the devices enable geologists on Earth to map a section of the Moon's interior, although more in-depth research required active seismic procedures. Upon reaching the Moon, the Apollo 14 crew brought the initial seismic experiment package featuring a specially designed mortar, geophones, and 22 explosive thumper charges. The mortar, activated by astronauts, could launch grenades up to 1.5 kilometers away. However, only NASA's radio command on Earth could fire the mortar. The astronauts successfully fired 13 of the 22 thunder charges, with misfires attributed to dirt acclimation in the firing switch. While serving their purpose, concerns about damaging other equipment prevented the astronauts from firing the mortar again. NASA's attempt to fire the explosives after the crew departed proved unsuccessful, leaving the explosives on the Moon to this day. The task was then assigned to the Apollo 16 crew, which successfully launched 3 grenades from a distance of around 900 meters. The mortar rounds, fired over strategically positioned geophones, recorded the blasts and seismic waves. However, the pitch sensor malfunctioned, preventing the firing of the 4th round, as the astronauts suspected it was a malfunctioning grenade. Apollo 17 encountered a breakthrough in the process of collecting lunar data. Astronauts, including geologist Harrison Schmitt, strategically placed explosives 3.5 kilometers from the lander. The charges were triggered by a thermal timer after pulling the pin. Both natural and artificially generated seismic waves were closely monitored. The artificial waves resulted from shotgun-like charges fired by an astronaut-operated thumper device and explosive grenade charges from a mortar box assembly. The explosives detonated after Apollo 17 departed the Moon, leading NASA to determine that the basalt layer near the landing site was approximately 1.4 kilometers thick. Scientists also identified seismic velocities between 0.1 and 0.3 kilometers per second in the upper few hundred meters of the crust at all 3 landing sites. These velocities, lower than intact rock on Earth, suggested a fractured material resulting from prolonged meteoric bombardment of the Moon. Since Apollo 17, no further research attempts of this nature have been made. However, the data collected during these historic missions continues to be valuable for ongoing research. We appreciate your viewership. Kindly like and subscribe to our Dark Documentaries channels for more captivating historical content. Share your thoughts in the comments below about these distinctive assets used by the Apollo crews in their lunar missions.